back to another Math Dive in 5. My name is Rebecca Ore and I'm the Math DRT. Today we're going to be talking about first grade fractions. We're going to have you start just like we do every other Math Dive in 5 with a task. So I want you to pause the video and with your team or a partner, go ahead and solve the task below. As you're solving the task, think about what student learning needs to look like for students to be successful with a task such as this. Also, think about what misconceptions might some students run into. Welcome back. Now let's look at the progression with the best benchmarks. In kindergarten, students recognize flat shapes as two-dimensional and they use attributes to identify rectangles, circles, and triangles, regardless of their orientation or overall sizes. Students may have had experience separating parts of a whole, but this is the first time that students partition circles and rectangles into equal-sized parts and name the parts as fractions, such as halves or fourths. In second grade, they'll begin to do not only halves and fourths, but also introduce thirds. After using concrete models, students then start making connections by drawing lines to show how circles and rectangles can be partitioned into equal parts. So what did you think when you came up with 3 different ways for the circle or the rectangle to be cut into 2 equal parts? Were these any of the ways that you partitioned the rectangles? How did you know that the partitions made each part to be equal? Not only when we're doing this do we want students to be successful and looking at different examples, but we also want to make sure that we're exposing students to non-examples so that they can discuss similarities and differences and really define what equal parts is. In this unit, students are also expected to name parts as fractions such as halves and fourths. Throughout the unit, model precise language and vocabulary with phrases such as how many equal parts are in the whole. Listen for students to explain with similar vocabulary. Since there are 4 equal parts, the circle is partitioned into fourths. Throughout this unit, you'll also have some students come across some misconceptions. They may have trouble partitioning into equal-sized parts or not realize that they can partition equally in more than one way. So if you see this, have students create and explore examples of partitioned circles and rectangles in different sizes and orientations. Did you see how that circle spun around? We didn't change the way that it was partitioned, but just because I turned the circle a different way, the partitions are the same. Make sure that students see many different sizes and orientations. Another misconception that students might have is that when a rectangle is divided into fourths using its diagonals, students may have trouble seeing that all parts are the same size. If you see this, it should not be a point of contention, but it should be an opportunity to explain to students that they will get a deeper understanding of this in later grades. These 2 rectangles are partitioned in equal parts. Now, hopefully you have a better understanding and feel better prepared to help students with partitioning circles and rectangles into equal halves and fourths and using that language to name fractions. You're building the foundation for fractions and it starts right now. That's it for this Math Dive in 5. We'll see you on the next one.